Hello, my name is Armando Huigochea, and today we're going to talk about chemistry. More specifically, about the gas laws. I'm going to give a definition, examples, and then I'm going to give a demonstration with an experiment about these gas laws. The gas laws that we are going to talk about is the Charles law and the Boyle's law. We're going to start with the Charles law. The Charles law is a law of gas that includes volume and temperature. This is a direct proportionality between pressure and temperature. Because when the temperature increases, the pressure also increases, united by a constant of pressure. The pressure here is a constant. It's not a unity included in the equation of this gas law. This gas law is one pretty simple to understand gas law because it's just a proportionality directly between volume and temperature. Like we can see in this graph, the black bar, it means the pressure constant, and we can see how when the volume increases, the temperature also increases. That's why it is a direct proportionality. Some examples that we can see about this law is, for example, a aerostatic balloon, because when we start the fire in the inside of the balloon, the temperature starts to increase, and also the volume. That's why we can see that the balloon starts to open, and that's the reason that allows these balloons to fly. And this is a perfect example of a Charles law in our daily life. The example that we are going to use today, it's a little bit different, but it follows the same law. We are going to boil milk. Why? Because when we boil the milk, the temperature inside the container that we're going to use starts to increases, and the volume also of the milk starts to increases as equal. And also it is used the constant of the pressure. Step we are going to use is to start putting the milk on this container because it is where we are going to boil it. Extra data, this experiment follows the rule because, as I already said, the Charles law is a directional proportionality between volume and temperature. This is the first look-alike of the milk inside the container. As we can see, is normal milk. It is just inside the container, and then we're going to start to increase the temperature. This photo is 2 minutes after I start increasing the temperature of the milk. As we can see a little bubbles the size of the milk, and the container already was hot. We can see also that it is releasing vapor. This means that the temperature is increasing a lot, and this is how the milk is increasing its volume. So let's see what happened after. Continue increasing the temperature inside the recipient of the milk. 60 seconds after, we can see another change inside of the milk. We can see like it is starting to get volume. I don't know, it is starting to increase his volume. We can see the level that is higher than when we start and higher than after 2 minutes being increasing the temperature inside the container. We can see that the milk is having physical changes, but also we can see that when the temperature is increasing, this is the most important part, that we can appreciate how the temperature is increasing and also the volume is increasing, because it isn't the same level that when we start. It is more, it has more milk and it has more level, so we can appreciate this change. Video of the final reaction. Thanks for your attention, and I hope you enjoyed this whole explanation, and see you next time.